In this video, we're going to be looking at different types of forces. And a force is simply a push or a pull. And we can use a spring scale like this one to measure forces. We can hang something at the bottom. We can also push something on it, and that will tell you how much force is being exerted on that spring scale. So first, we're going to define a force. So a force is simply a push or a pull, and it's measured in newtons. Okay. So now let's look at some different common types of forces that you might come across. The first is gravity force. So this is also known as the weight of an object. And the direction of the gravity force is always down, okay? And it's technically towards the center of the Earth, but usually it's just going to be down. All objects, and what objects have a gravity force acting on it? It's going to be all objects. So all objects on Earth will have a force of gravity acting on it. All objects on a different planet, or on the star, or on the moon. So anything on a large, close to a large mass, you will indicate a gravity force on it. Now, later on, you'll learn that there is a gravity force between any two mass, but for right now, we're going to typically just deal with things on Earth. So all the objects on Earth, there will be a gravity force acting on it in the down direction. Okay, the next force we're going to look at is something called the normal force. So I have an eraser right here. There's a gravity force pulling this eraser down towards the center of the Earth. But the eraser isn't falling down because there's another force acting on it. And that force is the table. So the table is exerting a force upward. And we call this the normal force. Sometimes refer to this as the support force. Okay. And this force is perpendicular to the surface. Okay, so what do I mean by perpendicular to the surface? So I mean 90 degrees. So let's say you have a ramp here, and you have a block right there. Okay, so this ramp is exerting a force on that block, and the normal force is going to be 90 degrees. Do you see that the ramp is along this direction, and the normal force is 90 degrees to the surface, like so, okay? So it's going to be perpendicular to the surface. If the surface is flat, then it's just going to be straight up. This is a result of the object pushing into the surface. So we can think of this as the atoms are crunched. It's not a very technical term, but gives you an idea that this is pushing against the ramp, and those atoms are crunched. So whenever those atoms are crunched, we know there is a normal force perpendicular to the surface. Next, we're going to take a look at tension force. And this occurs anytime you have a string, a rope, or a cable, or even a wire. You can exert a force on an object with that string. So here I have a ping pong ball, and I have a string right here. So if I push this over, I am exerting a force, and that force is a tension force. So whenever you have a string that is considered a pulling on something, that is tension. So right now I'm not pulling on it. It's not taut. So there is no force. I actually have to pull on it. Then you would have tension force. Okay, so the direction of this tension force is along the string. Okay, so the direction of it is going to be along the length of the string. Okay, so here's an example. Let's say that I have a string that's connected to this hook here. So I have this string right here, and it's holding on a block right here, okay? So this is a tension force. This right here is a tension force. It's pulling this block up right here, okay? And it's going to be an upward direction along the length of the string. And this occurs when the string or rope is taut. That means it's getting pulled. Okay. All right. We're going to move on here. The next one we're going to take a look at is friction. So friction occurs when an object is pulled or pushed along a surface. Okay. And there are two types of friction. So the first type of friction is called static friction. Static friction. And this is when the object is not moving. Object is not moving. Okay, so you might wonder, well, what would be an example of that? So example of static friction would be a ramp. So you have this ramp here. Okay. And I'm not going to draw the normal force because we know that there is a normal force. We talked about that a little bit. But let's say there's enough friction here, and that's due to the bumpiness of the surface, and it's not sliding down. Then we know that there is a friction going up the ramp, and we would label this Fs. That is a static friction force. Okay. And if it is moving, so for example, this eraser right now, there's friction. All right, I know there's friction because when I let go, it stops moving. And so this right here is called kinetic friction because it's moving. So I'm going to kinetic friction. And this is when the object is moving. Okay. All right, before I forget, let's go and label some of these so that we know what to call them. So this is static friction, so that's, okay. Let's go back here. This is going to be Ft, tension, okay, so Ft for tension. We also have normal. The normal force is Fn. Normal force is Fn, okay. And then if we have gravitational force, here's a ball going straight down, it's gravitational force, okay. So this is gravitational force, the symbol for gravitational force. This is the symbol for normal force. This is the symbol for tension force. And this is symbol for static friction, okay. How about if we have, how about if it's sliding down? So this is when it's not sliding down. I'm going to put V equals 0. It's not moving here. But what if it's sliding down? So let's do another one. And let's say this time that it's actually sliding down. It's actually going down. So this is going to be, it's going to have a kinetic friction. So this is going to be called Fk, all right? So Fk, it's moving, object is moving, there's friction because it's rubbing against the surface there. Next, we're going to take a look at air resistance. And this is a special type of friction force. It's going to be in the opposite direction of the motion. Opposite direction of motion. So anytime an object is moving through the air, so moving through the air, there will be some air resistance. And that air resistance will be in the opposite that it's moving. So for example, let's say we have a person is skydiving and has a parachute. Say here's a parachute, okay? So the air resistance, since this person is going down, all right, V going down, person's going down, the air resistance, and I'm going to call this FAIR for air resistance, or air drag, same thing, is going to be the opposite that it's moving. So it's coming down, so the air resistance is going to be towards the top direction, okay? And this occurs anytime something is moving through the air. Oftentimes there's not going to be not oftentimes, but sometimes there's not going to be a lot of air resistance. Air resistance depends on how fast the object is moving. And so if the object is not moving very fast, there's not much air resistance. Also the surface area, the cross-sectional surface area. So this parachute has a large cross-sectional surface area. So it would have a lot more air resistance. If I took this parachute and I scrunch it up together, there's probably not going to be as much air resistance.